models are usually used to describe the static static structure of objects and their relationships. And we know that because we have when we studied the state model, we know that state models are usually used to describe the state changes of each objects individually. And in this domain analysis stage, we also use the state models to describe the state change. It means that for some domain objects we have found in the domain class models, they have quantitatively distinct states during their lifetime. So we should first identify the domain classes with significant states and note the states of each class. Then we need to determine the events that take an object from one state to another. At last, based on the found states and events, state diagrams can be built. So the first step of building domain state model is to finding classes with states. It means that not all classes have different states. In the class models, in the domain class model, there are many classes found. It consists of many classes. Only several classes have distinct states. So we should first examine the list of domain classes for those that have a distinct life cycle, and we look for classes that can be characterized by a progressive history or that exhibit cyclic behavior. It means we should identify the significant states in the life cycle of an object. For example, for a scientific paper for a journal goes from being written to under review to accepted or rejected. This is a kind of cyclic behavior. And the ATM example, the account, is a class with significant different states. For the account, maybe normal, suspended, and so on. Then after we have found which classes will have different states or distinct states, then we need to find the details. It means we need to list the states for each candidate classes and describe them. Maybe you can use some statement to text-based statement to describe them. So how to find the different states for classes? Usually we need to focus on the attribute values that an object may have. It means we check the different attribute values. Maybe different values means different states. And we should also check the associations that it may participate in and their multiplicities. Maybe different associations or different multiplicity during the different life cycle or lifetime means different states, and attributes and associations that are only meaningful in certain states, and so on. So it means that we should check the changes of attribute values, and the changes of associations. And sometimes the state finding may be combined with event finding. It means that at the initial stage, maybe we cannot find all the states, and in the when we try to find event, maybe at that stage we'll find some new states. So it means that the state of finding states and events may be hybrid and maybe combined together. For the ATM example, there are three states for the account: normal, suspended, overdrawn. And for the normal and overdrawn, it may be determined by the balance. By the balance attribute of the account. It means that different balance values means it has different states. Maybe for normal, it means that the balance is larger than 0, and for the overdrawn, it means that the balance is smaller than 0. And suspended maybe because of some exceptions, operations, or some other maybe request by customers or suspended by the bank directly. So it is it is because of the associations with some other with some. It means that the suspended is associated with some associated with some different associations. For example, when the suspended may be associated with a customer and with a bank to determine whether to suspend. So it means that when you try to find states, you should check the attribute values and different associations. And after we have found states, we need to find events for the state diagram, because we know that for each state diagram, you should remember that for building a state diagram, you should first define states and then find the events associated with these states and some operations in response to this event. So the second step is to find the events, and we should find events that cause the transitions among states. So the event is the stimuli that causes a state to change. For example, for a journal paper, the first state is under review, and if get an event, it is the accept decision received, then it will go to the state accepted. If reject decision is received, it will go to the state rejected. And if revision decision received, it will go to the state under revision. So it means that the same state, under the same state, different events will cause different transitions. And this is an example for the account in the ATM example. It has three states is the normal, overdrawn, and suspended. In the normal state, if it gets the event withdrawn excess funds, then it will go to overdrawn state. And in the overdrawn state, if sufficient funds is deposited through ATM, it will go to the state normal. It means that the balance has changed. And in the normal, if you have input the password incorrectly more than 5 times, so it means that this is a kind of event. It will make the account to be locked or to be suspended. And during if the account is suspended, but if it is released by the bank teller, then it will go to the normal state. It means so you can check again. For the suspended state, it means that the release is associated with some bank teller. So account is a class and the bank teller is another class. So this kind of release is a kind of action. You do remember that action usually means there are associations. It means release hold is a kind of association with bank teller. And the user input the password means that their relationship between it is a kind of verb, means that there are some underlying or background associations between the account with some others. For example, with the cashier, with the customer, it means that this is another kind of association. So it means that during the different associations may means different states for the class. It means that different states is associated with different associations and attribute values. So this is a very classical example. It guides us how to find the states for a class. It means that we usually first to check the different values available or candidate values for the attributes, and we should also check some specific associations or different associations during the life cycle, because usually different associations usually also means different states. So after we have found states, events, and we can draw a state diagram. This is the state diagram for the bank account. It's a normal, overdrawn, suspended, closed. So this is the initial state. Go after open account, it will go to normal. If you close account, it will go to closed. If withdraw excess funds, go to withdraw. If you deposit sufficient funds, go to normal. And if you suspected fraud, it will go to suspend. And if released hold, it will go to normal. And administrative action also can lead to suspension or repeated incorrect PIN and so on. So it means that the state diagram, this kind of state diagram is used to describe the life cycle of objects. And the interaction model is seldom important for a domain analysis. During domain analysis, the emphasis is on key concepts and deep structure relationships using class diagram and state diagram. So there are some tips for domain analysis. We should iterate the analysis. Most analysis models require more than one pass to complete. And we cannot approach a fine application design in a completely linear way. It means we should attach the analysis iteratively to understand a problem with all its implications. And we should also refine the analysis model. The overall analysis model may show inconsistency and imbalance within and across models. So we should iterate the different portion to produce a cleaner, more coherent model. Refine classes to increase strength and improve structure by using hierarchical structures and so on. And we can also add some details that you glossed over during first pass or second pass. Then we may need a third pass or fourth pass. So we should do the analyze iteratively. And we should also restate the requirement. When the analysis is complete, the model serves as the basis for requirements and defines the scope of future discourse. It means the domain class model and domain state model as the basis describes the basic requirements of the system, and you should verify the final model with the requester, means with the customer. During analysis, some requirements may appear to be incorrect and impractical. So we should check with the customer or sometimes with the business called business experts to communicate with them to verify whether the analysis model describes the real world correctly. And we found that analysis models, it means that domain class model and domain state model, are effective means of communication with business experts who are not computer experts. And because they are not computer experts, so we cannot discuss with them using use codes. So the analysis models